So my question is homework 2, 16.9. And so it gives a picture of this circle and it asks about it says that they have wavefronts of a circular wave and it asks for the phase difference between points A and B in the first part. So one of the equations we were given about phase difference is that delta phi is equal to 2 pi delta x over lambda plus delta phi naught. And so in this situation, delta phi naught is 0 because it's all originating from this original source in the center. So we can completely disregard this. So all we have left is delta phi is equal to 2 pi times delta x over lambda. And so now we know that delta x in this situation is also 0 because they're on the same wave crest, and therefore there is no difference between the 2 points. And so here delta x is equal to 0. So when we solve, delta phi is equal to 2 pi times 0 over lambda. And this just simplifies to 0. So we know that the phase difference between point A and point B is equal to 0. Now for part B, we're asked the phase difference between C and D. And so we know that the distance between each wave crest is 1 lambda. So now using the equation that I used before, delta phi is equal to 2 pi delta x over lambda plus delta phi naught. And delta phi naught, like before, is also 0. So now delta phi is equal to 2 pi delta x over lambda. So now we can count the wave crests between the 2 points. So we have 1 wave crest, 2 wave crests. So the distance is 2 wave crests. And since the distance between C and D is 2 wave crests, delta x is 2 lambda because the distance between each wave crest is 1 lambda, like said before. So now plugging it into the equation, delta phi is equal to 2 pi times 2 lambda over lambda. And the lambdas cancel out, so what we have left is 4 pi. And so now delta phi is equal to 4 pi. So now for part C, we have to find the phase difference between E and F. So like mentioned before, the distance between 2 wave crests is lambda. And so now looking at this picture, we can see that E is in the middle of 2 wave crests. And that just means that E is at a trough. And F is on the wave crest, so it's at a crest. And so now we know that the distance between 2 wave crests is lambda. So the distance between the wave crest and the wave trough should be half of that distance because the wave trough is in the middle of 2 crests. And so the distance between E and F should be half lambda, which is the same as delta x. So now using the equation that I used before, delta phi is equal to 2 pi delta x over lambda plus delta phi naught. And phi naught is 0, so delta phi is equal to 2 pi, and we can plug in half lambda for delta x, which is just 0.5 lambda over lambda. And the lambdas cancel out, so it's delta phi is equal to 2 pi times 0.5, which is just 1 pi. And so the phase difference is pi.